Hey, MathKook here. This video contains one of many examples in my Algebra 2 library. The rest of those examples, along with hundreds of other videos, are only available at mathkook.com. Let's MathKook it up. Hey Kooks, this question says, find the inverse of the matrix A here. A is a 3 by 3 matrix, and they want us to find the inverse using the traditional method. Well, what is the traditional method for finding the inverse of a 3 by 3 matrix? Here are the steps. So step number 1 is we're going to add the 3 by 3 identity matrix, which is shown right here in blue, separated by a vertical line. So here's our original matrix here, matrix A, given by these numbers or letters. And then we have a vertical line, and then we write the identity matrix to the right of the vertical line right here. Next, step 2, we're going to use row operations. We're going to transform the matrix so the identity matrix ends up being on the left. So step number 2 involves many steps. So I don't want to oversimplify step number 2. Make it seem very easy by just writing that, but it actually consists of many steps, and we'll go through this example in a minute. So once you do that, so you transform this identity matrix to the left through a series of row operations, whatever's on the right, whatever numbers are here, that is our inverse matrix. So this matrix right here would be A to the negative 1, or the inverse of matrix A. All right, so it's that simple. So let's go ahead and apply this to our matrix given here, A. So I'm going to erase our steps here. And let's bring up our matrix along with a lot of the steps that are going to happen. All right, so we start with our original matrix. Notice this matrix here is this matrix here given. And then we write our identity matrix just to the right of it. So 1, 0, 0, 0, 1, 0, and 0, 0, 1. All right, so now the transformation must begin. So the first thing I want to notice is that we have a 0 here, but remember, we don't want a 0 on the top left. We actually want a 1 eventually. So I'm going to go ahead and switch row 1 and row 2. That's an operation that we can do. So I'm going to write this here, row 1, and then arrow switching with row 2. All right, so let's go ahead and just switch those rows. So 1, negative 4, negative 2, and then this will become 0, 1, 0. And then instead of row 2, I write row 1. So 0, negative 3, negative 2, 1, 0, 0. And then row 3 just stays the same. All right, so here is our new matrix. Notice the 1 is here, which is really nice. So remember, we want to get our identity matrix on the left here. So we want this here to be a 0, the negative 3. So I'm going to underline the negative 3. So our goal right now is to make that negative 3 a 0. All right, so to do that, we're going to use the top row. So what should we multiply the top row by so that this negative 3 becomes a 0? Well, hopefully you said 3. So we're going to multiply the top row by 3. So it's going to be 3r1 and then plus r3. And we always get to choose which row we're going to change. So in this case, we want to change r3 so that this becomes a 0. So let's go through the steps. So 3 times 1 gives us 3 plus minus 3, which is 0. So I'm going to write that here. So our new value down here is going to be 0. And then 3 times negative 4 is negative 12, plus 4, which is negative 8. And then 3 times negative 2 is negative 6, plus 1 gives us negative 5. 3 times 0 is 0, plus 0 is still 0. 3 times 1 is 3, plus 0 gives us 3. And then lastly, 3 times 0 is 0, plus 1 gives us 1. All right, so now we have our new bottom row. And the first two rows we're just going to rewrite here. So we'll have 1, negative 4, negative 2, 0, 1, 0. Okay, great. So now our goal is to make this here a 0 and the negative 4 is 0. So we want the negative 8 and the negative 4 to become zeros. So again, we're trying to transform the left side so that it's the identity matrix. So notice this looks great, 1, 0, 0. Now we want 0, 1, 0. So let's go ahead and and transform this, we have to use row 2 to make either of these rows a 0. So this one's going to be a little bit more tricky because we have to multiply row 2 and row 1 by numbers to make the -4 a 0. So let's multiply row 2 by 4. So if I multiply row 2 by 4, so it'll be 4 row 2. And then what would we have to multiply row 1 by? Well, hopefully you said -3 so that they'll cancel out. So -3 R1, and R1 is the one we're going to rewrite. And then while we're on this step, we want to make this a 0 as well. So what should we multiply the middle row by? We need to multiply it by 8. So we're going to go 8 R2, and then minus, what should we multiply the bottom row by? Well, 3 R3. All right, and we're going to rewrite R3, so I'll box that guy. All right, so a lot of computations here. Let's go ahead and perform the top one first. So 4 times R2, so 4 times 0, minus 3 times 1. So that gives us -3. So we're going to have a -3 in the top left here. Oops, we'll change that to white. All right, next we have 4 times -3, which gives us 12. Sorry, -12. And then -3 times -4, which is +12. -12 plus 12 is 0. And remember, that was the whole point. That's why we did this step here. We wanted the -4 to become a 0. All right, let's keep going. 4 times -2 is -8. -3 times -2 is 6. -8 plus 6 gives us -2. All right, so 3 more to go. 4 times 1 is 4, plus -3 times 0. So that's just 4. And then 4 times 0 is 0, minus 3 times 1 is -3. And then 4 times 0 plus -3 times 0, that's just 0. All right, so now we have our top row here. Now, the middle row stays the same, so I'm just going to rewrite that one. So 0, -3, -2, 1, 0, and 0. Okay, cool. Now the bottom row is going to become, we have 8 times R2, so 8 times 0 is 0, minus 3 times R3, which is 0. So 0 plus 0 is 0. And we want that to stay at 0. All right, and then next is 8 times -3, which is -24. -3 times -8 is +24. -24 plus 24 gives us 0. And remember, that was the whole point. That's why we did this step, to make this a 0. All right, we'll keep going. 8 times -2 is -16. -3 times -5 is +15. So -16 plus 15 is -1. All right, 8 times 1 is 8. -3 times 0 is 0. 8 plus 0 is 8. All right, and then we have 8 times 0, which is 0. -3 times 3 is -9. So we get -9. And lastly, 8 times 0 is 0. Minus 3 times 1 is -3. All right, we're getting a little closer here to our identity matrix on the left. Next, we want to make this -2 and this -2 0. So I'm going to underline those to show that we're trying to make these two -2 zeros to get into our form where we have an identity matrix of just 1, 1, 1, and then the rest are zeros. All right, so we have to use R3 to make each of these zeros. So what should we multiply R3 by so that we get our R1 here, this -2, a 0? Well, we want to multiply by -2. So we're going to go -2 times R3 plus R1. And we're going to rewrite R1. And then the same thing for R2. We want to make this -2 a 0. So we're going to multiply the -1 by 2. Sorry, -2. So -2 R3 plus R2. And again, we're going to rewrite R2. And this will ensure that both these guys become 0. All right, so let's do the work. So let's start with the top one. -2 times 0, which is row 3, plus -3, still gives us -3. -2 times 0 is 0, plus 0 is 0. And then -2 times -1 is 2, plus -2 is 0. And again, that was the whole point. That's why we're doing this step, to get this guy to be a 0. Next, we have -2 times 8, which is negative 16, plus 4, which is negative 12. All right, and then negative 2 times negative 9 is 18 minus 3, which is 15. And then lastly, negative 2 times negative 3 gives us 6 plus 0, which is 6. All right, next we do the middle row. So we're gonna use this operation. Negative 2 times 0 is 0, plus 0 is 0. Negative 2 times 0 is 0, plus negative 3 is negative 3. And then negative 2 times negative 1 is 2, minus 2, which gives us 0. And remember, that was why we did this step, to get this guy to be a 0. And then next, negative 2 times 8 is negative 16 plus 1, which gives us negative 15. And then negative 2 times negative 9 is 18 plus 0, which is 18. All right, and then negative 2 times negative 3 is 6 plus 0, which is 6. All right, so now we just rewrite the bottom row. That one's not going to change at all. So 0, 0, negative 1, 8, negative 9, and negative 3. All right, so here is our matrix. We're so close. We almost have the identity matrix on the left here. We just need to go one more step and write, we want each of these numbers here to be a positive 1, and then it'll be the identity matrix. So we can multiply each row by whatever number we want. So in this case, what should we multiply the top row so that this becomes 1? So hopefully you said negative 1/3. So we're going to multiply the top row by negative 1/3. And then same thing with the middle row, so that becomes positive 1 right in the middle here. And then what should we multiply the bottom row by so this becomes positive 1? Well, just negative. So negative R3. All right, so now we can multiply through. So I'm going to multiply negative 3 to all these numbers in the first row. Sorry, negative 1/3, I should say, to all these numbers here. So when we do that, we get 1, 0, 0, and then positive 4. Negative 1/3 of 15 is negative 5. Negative 1/3 times 6 is negative 2. And then now we multiply negative 1/3 to the middle row. We get 0, 1, 0, positive 5, negative 6, and negative 2. And then lastly, the bottom row, we just multiply by negative 1, which basically just changes the sign of all of them. All right. So notice here on the left, we have our identity matrix. So this is fantastic. So now we've transformed the identity matrix all the way from the right here through a series of row operations here, and we've transformed it to the left. And then now on the right here, this is our inverse matrix. So I'm going to go ahead and erase our work here, but no, this is our inverse matrix. I'm just going to rewrite that. So I'm going to erase all of our work and then just rewrite that matrix, and that is our inverse matrix. Our inverse matrix here, so A inverse, is going to be 4, negative 5, negative 2, 5, negative 6, negative 2, negative 8, 9, and it was 3. All right, so there is our answer. So there is the inverse of matrix A. Hey Kook, if you found this video helpful, hit that like button, subscribe, and drop a comment. For unlimited access to all of my Algebra 2 videos, visit mathkook.com. Thanks for watching.